Guys, if you have not followed me, try and hit the follow button, please. We are doing a lot of work here. I have this question on rate of diffusion. The rate of diffusion of a gas Y is twice that of Z. Take note. If the relative molecular mass of Y is 64 and the two gases diffuse under the same condition, of course, find the relative molecular mass of Z. We all know about Graham's law of diffusion. Graham's law of diffusion simply says that at constant temperature and pressure, the rate of diffusion is inversely proportional to the square root of the vapor density. Yes, so it simply means that rate of diffusion is inversely proportional to the square root of the word the vapor is inversely proportional to the word the vapor density. It simply means that if you introduce your constant K, it simply means that R1 over R2 is equal to square root of D2 over D1. And this expression is also correct as M2 over M1. Remember that when you talk about vapor density, it has a relationship with the relative molecular mass. We know that vapor density, or 2 times the vapor density, is equal to what? The relative molecular mass. So this expression is correct for the rate of diffusion according to Graham's law. So R1 over R2 is equal to square root of D2 over D1, which is also equals to square root of the relative molecular mass M2 over M1. Have this at the back of your mind. So in this case, we are considering the rate of diffusion and the relative molecular mass, right? So that is to say that the expression we are going to use here will be diffusion of Y is twice that of Z. That is to say, we have R Z, that is the rate of Z, and we'll also have R Y, that is the rate of Y. We have the relative molecular mass M Z, that is the relative molecular mass of Z, and also we have the relative molecular mass of what? Y, guys. I want to express something here before we continue. Now, the rate of Y is twice that of Z. Remember, we do not know any rate, but they are telling us that the rate of Y is twice that of Z. So, if